All right, so the next thing we're going to look at example 3. But before I do that, I just want to go over something that I said earlier. So we looked at the issue of solving an equation using a graphical method, and this is what we said you should do. On the same axes, which essentially means on the same graph sheet, using the same axes, you're going to draw the graph of the left-hand side of the equation and the graph of the right-hand side of the equation. And the solution for the equation would be the value of x where the two graphs meet. So whenever you are asked, and you're going to see it in the future, you're going to be asked to use graph to solve an equation. Whenever you asked to use graph to solve an equation, on the same graph sheet, you must draw the graph of the left-hand side of the equation, draw the graph of the right-hand side of the equation, and the solution would be the value of x where the two graphs meet. How do we use graph to solve simultaneous equations? Well, this says on the same axes, we're to draw the graphs of the two equations, and the solution of the simultaneous equation are the values of x and y where the two graphs intersect. All right. And I'm quite sure that this issue of solving equation and simultaneous equation using graph is going to come up again. Example 3, this says, using the graph sheet provided on page 62, I'm sure it's not 62, but you will find it. Using a scale of 1 centimeter to represent 1 centimeter to represent, this should be 1 unit on both axes. We're asked to draw these two graphs. All right, so let's go and prepare the graph sheets. All right, so let me use a different color here. Let me use maybe black. So let's label our axes. This is the origin. The scale is 1 centimeter to 1 unit. So every centimeter, 1 centimeter to 1 unit on both axes. So every centimeter on both axes, the number goes up by 1. Please note that whenever I'm labeling my axes, I always put my numbers on the major grid lines. So the highest value of 12 I can have in my graph. Sorry, the highest value of y I can have in my graph is 12. All right. So so I prepared my graph sheet. The highest value of x is 11, the highest value of y is 12. So I need to draw these two graphs. So remember, to draw a straight line graph, you need 2 points. So let's take the first graph and get the 2 points. We have 2x plus y is equal to 11. So y is equal to minus 2x plus 11. I need two coordinates of points on this line in order to draw it. So I'm going to select a value of x. Please note the gradient here is not a fraction. So I don't need to be, I don't need to be selective in terms of what I choose for x. Well, you need to be and don't need to be at the same time. So I don't have to select a particular value of x. I can select any value of x within reason. So I'm going to say, let us say when x is, let us say, equal to 1. All right. And y would be equal to minus 2 times 1 plus, plus 11. So this is minus 2 plus 11, which is 9. So the coordinate of my first point is 1, 9. So 1, 9 is a point on this graph. I need 2 in order to draw my straight line graph. Same equation. Y is equal to minus 2x plus 11. I'm going to select another value of x. Sorry, ensure that they're not too close to each other. So I might say when x is equal to, let us say, 6. Y would be equal to minus 2 times 6 plus 11. So notice I select x is equal to 1 first, then x is equal to 6. They are, understand, they are a little distance apart. They're at least 5 centimeters apart. You don't want them to be too close. So this is minus 12 plus 11, which is minus 1. So this point is 6 minus 1. So 1, 9 and 6 minus 1, I can plot the 2 points. Sorry, 1, 9 is here. 6 minus 1 is here. All right. And I can draw my straight line through my points. All right. I'm using technology to straighten my line. You must ensure that you use a ruler. Once you use a ruler, you should be fine. Everybody should know that this straight line cuts the y-axis at 11. All right, doing it over. All right. So as I said, you must use a ruler when you're drawing this. All right, once it's properly lined up, you draw a straight line and then you label the line. This is the line y is equal to minus 2x plus 11. Gradient is minus 2, it cuts the y-axis at 11. I need to draw another straight line. We need to draw the line of, we have 3x minus y is equal to 4. We have 3x minus 4 is equal to y. Turn it around, we have y is equal to 3x minus 4. I'm going to say when x is, let us say, equal to 2. Y would be equal to 3 times 2 minus 4. 6 minus 4 is 2. So this is the point 2, 2. I need 2 points for a straight line. So I might say when x is, let us say, 6, y would be equal to 3 times 6. All right, I don't think I want to use 6. Because if 3 times 6 is 18, 18 minus 4 is going to be 14. So y is going to be 14. And y is going to be 14. And the highest my graph goes to is y being 12. So I can't use 6. Because when I use x is 6, I'm going to get y is 14. And that point is not on my graph. It's a point on the line, but it's not on my graph. So I might use when x is 4. 3 times 4 minus 4. This is 12. Let's use 5. When x is 5, 3 times 5 minus 4 This is 15 minus 4. This is 11. So this is the point 5, 11. 2, 2, 5, 11 are the 2 points I need. So let's change the ink. 2, 2. And 5, 11. All right. And this is, okay, 3x minus 4. All right, let's draw a straight line. So you line up the 2 points with your ruler. Draw a straight line through them. All right, so this line cut the y-axis at -4, and it must pass through these 2 points. All right, I think we're almost there. Almost. Yeah, this is the line of y is equal to 3x minus 4 and this is the line of y is equal to minus 2x plus 11. So we have just drawn the 2 graphs, drawn and labeled the 2 graphs. All right, the 2 graphs intersect here where x is 3. So this is x is equal to 3 and y is 5. This is the line y is equal to 5. So the point of intersection is the point 3, 5. So point of intersection is 3, 5. All right, going back up, let's look at the questions they ask. The first thing we're asked to do is to use the graph to solve the simultaneous equation. I already told you, to use graph to solve the simultaneous equation, you have to draw the 2 graphs, which we already did. And that the solution are the values of x and y at the point of intersection. So the point of intersection is where x is 3 and y is 5. So x is equal to 3 and y being 5 are the solutions of this simultaneous equation. Next, we're asked to use the graph to solve an equation. We're at C. Guys, this is what I said to you. If ever you're asked to use graph to solve an equation, you must draw the graph of the left-hand side and the graph of the right-hand side. On the left-hand side, we have y is equal to 3x minus 4, already drawn. On the right-hand side, we have y is equal to minus 2x plus 11, already drawn. The solution are the values of x where the 2 graphs meet. Remember, where the 2 graphs meet, the solution is x is equal to 3. Because x is equal to 3 is the value of x where the 2 graphs meet. And if I wanted to, I could use calculation to show that x really is equal to 3. I could use calculation to do it. This is 3x plus 2x is equal to 11 plus 4. 5x is equal to 15. Divide both sides by 5. Using calculation, x is equal to 3. Using graph, x is equal to 3. To use graph to solve an equation, you must draw the graph of the left-hand side of the equation, draw the graph of the right-hand side of the equation. The solution are the values of the solution is the value of x where the two graphs meet. I don't think that there's anything more to the question. I don't think so. All right, so x is equal to 3 and y is equal to 5 for the simultaneous equation, and x is equal to 3 for the equation. All right, and that's the end of the question.